Hi, we have the AP Physics 1 past paper 2019. We are discussing free response question section. Now there is a question 1 for the 7 points. In this question, there is a two identical blocks 1 and 2 placed on a horizontal surface at the points A and E as shown in this figure. Okay. The surface is frictionless except the region between C and D. In this region, there is highlighted a frictional part. So, where the surface is rough, beginning time TA when block A1 is pushed with a constant horizontal force from point A to B, this plunger provides the mechanical pull to the block A. Upon reaching the B, block loses the contact with the plunger and continue moving right with the horizontal surface block 2. Mean at this point the plunger loses its contact with the A. Onward from here to here, the block 1 reaches to block 2 and the block 1 then collide and stick with the block 2. From here, block 1 when reach, it will stick with the block 1. Okay. Now two block system continue moving across the surface, eventually passing through the F. Both blocks then passes through the F from 1 and 2. Okay. Now question is on the axis below sketch the speed of center of mass of two block system as a function of time from TA until the block passes point F at TF. The time at which block 1 reaches the point A through F are indicated as a time axis. Mean TA, TB, TC, TD and TE and TF all are indicated on the axis as shown in you have shown in the paper. Now, first of all, I discuss point to point, then I will become as a graph. Now, if you see TATB, there is a constant horizontal force from the plunger act on a block 1 to its direction rightward. So we consider net force on the system is F. External force is constant, so causes a constant acceleration mean the center of velocity increase linearly with the time. So I have this, if you can consider, let's say this is the constant velocity from here to here. Or you can see this is the constant velocity graph. So its velocity is increasing, then it's mean, but this increase in equal interval of time is equal. So acceleration is constant, so force is constant. Now, in time B to C, block 1 is moving. There is no plunger acting on it. The surface is frictionless. That's mean external force is 0. When external force is 0, mean acceleration is 0. When acceleration is 0, it's mean velocity. There is no change in velocity. So center of mass velocity remains constant. So you can see there is a constant velocity of the center of mass. Okay. Now C to D, the block 1 is moving, friction becomes the frictionless surface. So constant frictional force act, the friction opposes the motion, so its direction is leftward. So now external force is frictional force. So constant frictional force causes a constant negative acceleration, meaning VCM decrease linearly with time. But this constant force is not so much great that it can able to stop the blocks. So block velocity will decrease, but it will decrease uniformly. So as you can see, center of mass velocity is going to decrease, but it decreasing uniformly. So there is constant acceleration by the constant frictional force. And what happened to next? Block 1 collide with stick block 2. This is the considered system internal interaction. There is no external horizontal force, so F external 0, no plunger there, no frictional there, so there is no acceleration. Center of mass velocity remains constant. So you can see in this portion the velocity is constant. Now the two block system moving over the frictionless region, again it crosses the TE to TF. There is no external force, center of mass velocity remains constant. So this is the graph that can you show the whole journey of the two block system. In next part of the question, now the plunger returned to its original position, both blocks are removed, a uniform solid sphere is placed at the point A. The sphere pushed the plunger to the point A to B with the constant horizontal force that directed toward the sphere center of mass. Sphere loses the contact plunger at the point B, same as situation, but now the last time there is a block, now there is a sphere. Continue moving across the surface toward E, in which interval any does the angular momentum about center of mass changes. Check at all the apply. A to B, B to C, C to D, D to E, and none. So first of all, I provide the answer. There is C to D is the region where there is change in angular momentum of the sphere. Now why? Let's consider step by step. Angular momentum about the center of mass changes only if there is external force, net external torque acting about center of mass. So torque is rate of change of angular momentum. If torque is zero, that's mean there is no change and there is no change in angular momentum. If torque is present, there is change in angular momentum. Torque is R cross F or F sine theta n unit vector is this is n unit vector providing the direction, but we are only considering the magnitude. So R is moment arm, F is internal force, and theta is the angle between the moment arm and the force. Okay. Now, what step by step let's consider it from TA to TB. There are two forces, normal force and gravity force. If you consider the gravity concept, so both forces are passing through the center of mass. So moment arm becomes zero because we are considering center of gravity is passing from there. Normal is also passing from the center of mass. So there is no movement arm. R become zero. When R is zero, torque is zero. When torque is zero, there is no change in angular momentum. So the same situation when B to C, the only two forces are acting, normal force and gravity force, both are passing through the center of mass because we are discussing the change in momentum about the center of mass. Because a sphere is spherical symmetry, its center of mass lie toward its center. So if the particle or if the sphere has to change in momentum, it has to act through the, it has there should be an external torque act on it. So external torque, there should be moment arm. The moment arm is about the center. So these two forces are passing through center. So there is no moment arm. Again, in next part B to C, there is no moment arm. So change in angular momentum is zero. Then, if from what happened C to D, if the external force, normal and gravitational force is present, but these are passing through the center of mass, but there is a frictional that is acting at the bottom of the contact. Mean what happened? Let's say if we say that's the surface and what would be the gravitational force? So let's say there is the frictional force. So this frictional force has the moment arm from the center of mass that indicate with the R. So there is R F sine theta. So there is a torque present. So we can say there is a change in angular momentum. Again from D to E, there is no frictional surface. Now only again two forces, normal and the gravity. Both are passing through the center of mass. Both are the moment arm is zero, torque is zero. So there is no change in angular momentum. So that's the solution. If you have any query, kindly ask in a comment. If you like the content, kindly subscribe and share with your friends. Okay, take care.